Yeah.
Gotta be kidding. I don't know if it's going to mute me or not.
We're live.
It's screwing with me. Oh, Mike's got something live right now, so we should go to him for now.
Yeah, start from the beginning. Just start it over again. Pretend like you were quiet for the whole thing and just go right from the beginning.
That's fucking unbelievable.
So, for reference of everyone that's just tuning in on Jeremy's channel, Jeremiah was giving an excellent presentation of his bagel coil, which got cut off. So he's going to start over and do it again. But first, we've got Mike set up with his work. So we'll let Mike explain his, and then Jeremiah will start over with the bagel coil.
Unbelievable.
Yeah. So lately, I've been cutting some wheels on the water jet, and I got a ceramic bearing in the center, and I got 4 neodymium and 2 magnets. These things spin amazing. They're really, really good. So I've got the new wheel. I just purchased a new transducer. That one's about 1.5 inches in diameter. It's 60 kilohertz and 35 watts. And it's really good effects. Now, I'm also putting high voltage into the motor now. So this one's set at 100 volts, DC at 7 milliamps, and the results are quite dramatic. So I'll fire it up here. You guys can see it. Wires here.
Mike, you're super quiet. I don't know if you're far away from your mic or what, but...
Oh, okay, sorry.
There we go. Now Mike's on the mic. Sometimes it's covered...
Mike, in case you get to 88 miles an hour, what date have you set the thing to?
You gotta turn that down. Wow.
Is it too loud?
1.21 jigger.
Not you, Mike.
Oh, okay.
Oh, is it me? Is my mic really loud?
You came in like Zeus there.
21 gigawatts.
Thundering.
Better. Am I better here?
Yeah, that's better.
There you go.
Yeah, so yeah, the output of this is quite a bit higher now that I got the second transducer hooked up. So basically, I've been reading up a lot on what Newman was doing, and it's turning out that his theory is, I would say, correct. You got to put in a lot of voltage in, and it doesn't require current. As long as you got a big mass like that, that coil there is 1 pound of 24 gauge wire. And yeah, you can see the back EMF is quite intense. So that's a 60 watt rated bulb. So when I hook it up to the watt hour meter, it's actually 7 watts of true wattage. So I'm putting in 1.1 watts and getting out about 7 watts based on my readings from the watt hour meter. And it's all because of this little high voltage converter. So it's putting in 12 volts and getting 100 volts.
So you're getting that from the spin. You're getting that from the spin. Why could you not just use a bicycle wheel?
You could use any wheel you want. Like this one's quite small.
It's the coil that's feeding the light, not the wheel.
The coil is where the current is being generated. It's not by the battery.
Yes.
Doing that.
Yes, that's why I'm saying if it was bicycle wheel powered, it would eliminate any there's wires under the table claims from people, you know.
Yeah.
Yeah, this is real. This is a bulk.
No, I mean this thing is a super famous modification of a classic circuit called the Bedini schoolgirl circuit. It's a really simple back EMF wheel driver, and it generates power on the opposite side of where most motors do. Most motors will push and pull, so you have a continuous coupling from the rotor to the stator. And in this case, the stator doesn't exert much force on the rotor, but the rotor is then hit by the back EMF. And so right at top dead center, where it's the most efficient in closest proximity before it has a chance to move away, it gets this big pulse at the most efficient point. And the point
so
is
that whole effect sensor is flipping the waveform.
It's triggering the I'm using the
back EMF is flowing. Back EMF is flowing out the 1N4007 HV diode, the high voltage diode. That's where it's going. It's going the reverse polarity. When you energize the coil, plus and minus. When the back EMF happens, it's going to be minus plus. It's going to reverse polarity. It's going to go out the high voltage diode, which is arranged in a direction for the reverse polarity.
Right. So you're also
That's
looking
it.
at something different here too. So this isn't just the BDD. Yeah, this is not just the Bedini circuit. This is also an integration of Norman Wutan's oscillator, which uses piezoelectric elements to phase delay in a physical mechanical way, not just electrically, but to mechanically phase delay the signal, which allows it to interact with the external environment at a distance. And this is a very good way to basically separate the cause and effect from the input signal, where Lenz's law would normally affect and load it, and then the output pulse, where it's going to provide rotational motion and acceleration to the rotor.
Yeah, this motor's got a lot of torque.
Can you describe how that's happening, the piezo, how that's...
it's basically set up in parallel with the coil. The ideal spot would actually be right behind the coil. So it's like piezoelectrics. If you apply physical pressure onto it,
using force, what are you using for your piezo?
It's a barium titanate. Barium titanate, which is
just a piece of metal in parallel with the coil.
It's in parallel with the coil, yeah. But it's also getting hit with a disruptive discharge from the auto relay switch. I've modified it to actually trigger very fast. So it's getting a disruptive discharge. The back EMF ricochets, hits the transducer, and then you get that flyback. And as a result, you get huge output.
We're using the back EMF to vibrate the piezoelectric.
Yeah. Instead of putting a physical stress on that transducer, I'm slamming it with a voltage.
Right. The back EMF.
Yeah.
Right. So as the magnet approaches the solenoid, the polarity is attracted, which means that the magnet actually reduces the amount of power that it takes for polarization of the core material. And then when it flips around, there's no more power supply connected to it. So the power supply built up a magnetic flux by using the approach of the rotor and its magnets to reach a magnetic saturation point that's above the electrical energy input. And then when it goes back EMF, the rotor is moving away. And so instead of going completely negative, it basically just demagnetizes completely, but the motional magnetic field, or the amps per meter in terms of the magnetic flux, is now repulsive. And so you get the extra energy on sort of both sides depending on how you run it. And it's a delicate balance. Like, most of the stuff will go in losses. And a solenoid coil like what Mike's using right now is convenient, but it's really one of the worst kinds of coils to use because it has high internal self-capacitance, which is all parasitic for this circuit.
Which part has the high internal?
Sorry, say that again.
What happens if you disconnect
Where's
the
the high
battery?
internal capacitance here?
It won't run itself.
I mean,
It's
what's
made it
causing the high internal
extremely efficient.
capacitance? Is it the coil or is it the?
Yeah, the internal capacitance in the coil. Yeah, definitely. Yeah. When you
Mike,
get the
sorry to interrupt, Mike. Is this the one when you unplug it, it starts, it stops, and then it starts spinning in the opposite direction, and then accelerates in the back?
Yeah, it works with capacitors. Yeah, it'll run down basically down to about half a volt, and when that occurs, it slows down. It bounces back and forth, and then starts spinning in the opposite direction, and I could get about another 15 minutes of run time with less than a half a volt.
I wonder if that's because the potential across your solenoid is causing parasitic losses due to self-capacitance. Wow, hey, check this out, awesome. I wonder if it's because you have parasitic capacitive losses in your coil, and if you wound your solenoid differently, or if you didn't use something with such high internal capacitance, it would allow you to operate at a higher voltage before it started to do that.
So what? Well, more windings or less windings?
Yeah. So
It's
what
not
does
about
this
more or
do?
less.
You
They
want
have
to give it more
to be
voltage, you
spaced.
want to give it more windings.
It's not about more or less windings. It's about the capacitance between the windings. They need to be physically farther away from each other, which means magnet wire on a tight wrap is about the opposite of what you want. You could wind a spaced solenoid and then insulate the layers, or you could wind a totally
Okay.
different type of coil, like say a pancake or something with spaced windings, and then do multiple pancakes stacked on top of each
Oh,
other
I see.
in order to get rid of
Okay, I
that
see.
problem. Yeah, you'll
Yeah,
notice all
see,
of Tesla's oscillators, all of his secondary coils and his extra coils are spaced out, much unlike today's Tesla coils. He always uses at least double spacing or triple spacing to the thickness of the wire between conductors, and that's extremely important.
Yeah, I've been noticing that people are saying that we should space the coils, not understanding how that's making,
Right.
what role it plays in your efficiency.
Yeah, back in the day, there used to be something called a weave wound coil, and it was a zigzag back and forth three-dimensional coil where most of the wires were kind of semi-orthogonal to each other. When they crossed over, they crossed at a narrow point, sort of like a star coil, but along the other axis, built tall instead of wide. And that significantly reduces the self-capacitance and allows you to capture this back EMF effect and the local refractive index change much more effectively without the losses.
So the
Now that we
goal
got
is to
Jiro, he can talk
lose-
on this because that's how his coils work.
So spacing the coil, it helps lose the inductive reactance.
Right, it gets rid of it almost.
Why would you want to get rid of the inductive reactance?
So
Because it's parasitic.
How? How's that?
what,
It slows down the
think that's-
signal, which reduces the maximum volts per meter of the radiated field.
Mike? What are we doing with this thing? Why are we building this, and what does it do?
Well, I'm testing out the theory, you know, to eventually get it to the point where it can recharge itself and maintain its own power source, right? So it will eventually be looped. I'm just trying to get the science down first, right? And I've been working on this for 5 years, and then all of a sudden I figured try to hook up a transducer to it, and my gains quite a bit higher. So I knew I was onto something, and I just kind of went with it. It's just a lot of it's experimentation. You just got to get on the bench and do it, right? Try different ideas. I've always got new ideas running through my head how to improve this thing, right? But as far as efficiency is concerned, I really feel that I really think
Your mic
that
again there.
I can't hear anything he's saying. Can any of you?
No,
Yeah,
I know,
Mike,
I'm
I
just
think
saying
you're
because-
covering your microphone on your cell phone the way you're holding it. That happens to me when I'm recording sometimes. And welcome, Gerald. Thanks for joining.
Well,
Can
I
you guys
was
hear me now better?
Yes, we can.
Okay, yeah, it was my headset that was dying, so I had to switch it. Yeah.
Slowly,
So yeah,
slowly
I think
out.
so. I personally, I think it's Newman was really onto something very correct as far as putting high voltage at a low current and then hitting a large mass. Mass is where the current is generated. Put a high voltage in a coil, the current's going to be generated in that coil.
Yeah, with I'll mention this about his system too.
Sorry, guys.
first they had friggin' Jeremiah was presenting and his audio cut out right when I was going live.
Yeah.
And then now Mike's trying to present his stuff. I can't hear a goddamn word he's saying.
Sorry. Can you hear me now?
We can a bit now. Jeremiah, do you want to go back and
Yeah, we can
restart
do that
the
now.
bagel coil now? And thank you, Mike. Awesome work, Mike Faraday Research.
Yeah, let's go. Yeah, the bagel thing was interesting. I want to know what's going on with that. So that
Just
I
testing
also
my mic. Can
think it
anyone
would be
hear
cool to show that
I can hear you, D, but you're quiet. You're very quiet. Everybody
you
seems
have
to have
those
audio
diagrams
today.
too. It would be cool to show like what feedback EMF is and how that you harvest that with the different transformer shape. But anyways, let's get into
So let me say something about back EMF. When you have the inductance, it's going to block your reception of back EMF, like Jeremy was saying. It's parasitic to the back EMF. Induction is. So with the Newman motor, by using a very low current, next to none if you can achieve that, and high voltage. And he was using 9-volt batteries that were all dead, and they had next to no current in them. That's a way of creating potential with very little induction. In other words, a system that will not block the back EMF.
Yeah, the less capacitance you have, the more potential you're going to instantaneously get, and the less losses, and that is really what you want. So I don't know. I'm guessing that when I was talking over the video, that audio came through. Is that right? So while I was playing the videos earlier,
but you might as well just restart your presentation from the beginning, Jeremiah, as we weren't live on the Alien Scientist channel, and then we went live and it's ended. So just begin from the beginning, because that bagel coil is next level, and what you're reproducing and experimenting with the Bob Greenyer Martin Fleischmann Memorial Project bagel coil is where the design's from, correct?
It's similar to his design, and that's where the motivation for that design came from. And what I did was several steps beyond what has been done so far with bagel coils. And I was able to do that much more easily because I found a way to make wire that almost self-winds and allows me to create even more complicated layered geometries. So the bagel coil is what we call a 3-tor. And I'll get into that here. So let me go ahead and explain this. I don't know. I think we just lose somebody. We got somebody there. Okay, so what we're looking at here, this is the Hall effect probe that I showed that I'll be showing a video of in just a second, since we're sort of restarting this. And this probe has a BNC connector on the end, a USB charging port, a power switch, a 5-volt step-up boost converter from this 3.7-volt battery, and then at the very end here we have a Hall effect probe, and that's a linear S49 probe, S49E. I'll show you a video of that in just a second, but let me just show you a couple of things since I've already got this email open. This is a transformer that I'm building, and this transformer uses a special kind of wire, which we'll get into in a moment. This wire is basically like a guitar string made of copper, and it's wound around a double magnet core. Now, very much like you'll see in Norman Wooten's stuff where he uses a magnet, or what you have in the Manila system, here we're using a permanent magnet as a ferrite core. And the two north poles are stuck together in the center, and then it's wrapped around with this this double conductor wire where one conductor through the center is straight and the other is wrapped around. And so the reason for why this is actually important and why this makes it different from another transformer is what happens when we have two orthogonal fields. When we have an electric field that's on one axis and we have a magnetic field that's naturally 90 degrees to it. Well, normally we can only pick up one of the two fields with the conductor, like the two that are parallel, say two coils of a transformer that are parallel with each other. Well, in this case, all the windings that roll around this toroidal core, wrapped around it like a conventional transformer, are surrounded by another set of windings that are orthogonal to those and don't induce a current into the core. All they can do is basically induce a change in epsilon surrounding the conductor that goes around this core. But epsilon and mu are what define the speed of light, and they define the interaction with the magnetic system like this one with the outside environment. So here we can pass current through the outside wrap and change epsilon for the inside conductor, whose epsilon is actually perfectly aligned with the one that we're changing, but whose mu is not affected. And this will allow us to convert Brownian motion from the ambient environment by creating a time differential where the force vectors of the accelerated motional particles, just due to thermionic motion, are now they're now curved in towards and extended along the gradient where the time is slower inside this core and inside this wire. And so those force vectors extend. And this is a direct opposition to Lord Kelvin's statement that you can't extract energy from the thermal basin because entropy has already nullified it. This is a Maxwell's demon situation where we're using a temporal differential, or a squeezing of electromagnetic energy, squeeze light effectively, to try and draw extra energy out of the system. Now that special wire looks like this when you look at it close, and here you can see that there's a center conductor running through and it's got this wrapped conductor. This is what the wire looks like, but the two conductors are actually the same size, unlike this picture. And this is another device that I wound with that same stuff. And this is a 14 by 14 by 14 torus. And so the three main toruses that are each orthogonal to each other, we have these ones here. Can you see my arrow, by the way? Can you see my mouse pointer?
Yeah.
Yes, sir.
Okay, good. So these ones here that are sort of wrapped around this core like this, they're orthogonal, but there's also a wire that's running parallel that it's wrapped around each of these loops as if it's a core. And then, of course, we have the core inside that, which has got other loops wrapped around a single loop, and then we've got another core inside that, which is orthogonal. So we have a total of 8 individual conductors here for 16 terminations. You can see the rat's nest here. And what's going to happen here is every single time we flip epsilon on u, compared to the center axis wrapping around this thing, we're adding a layer of field compression, one more boundary layer where the refractive index has to twist 90 degrees before it can reach the next. And this supports a sort of Matryoshka nesting doll style arrangement. And in doing these stacked fields, what we're doing is effectively slowing down the speed of light. So I should be able to take the center conductor of that coil and tell if, based on its inductance and the amount of time that it takes for a signal to pass through it, if I've slowed down the speed of light due to the fact there's no ferromagnetic elements anywhere in these 8 layers.
What I just envisioned and realized is that it's like the coil within the coil within the coil. It's the field within, or the bubble within the bubble within the bubble, as David Soretta likes to say, but you're actually incorporating the twisting, moving of essentially like the universe, galactical orbits and rotations of energy and everything and spin, that you've got essentially the gyroscope within that coil all in one as the energy movement.
Right. It is an electromagnetic gyroscope. So it takes the J-curl tensor, aka the torsion tensor, and the electric scalar, and it inverts them back and forth and layers them 8 deep. And what the reason why this is more interesting than just, say, a conventional stacked coil is each time you go one layer deeper, all the layers on the outside are affecting the layers on the inside. So we're talking about a sort of low energy warp drive effect, and we're not having to pump out all that power into one single area because each layer affects the next. And this will allow us to use all positive energy states to create a significant temporal distortion in the affected region.
Can I just say something?
Yeah.
The way that we would normally harness a dynamo, for instance, we spin a dynamo, and a dynamo is essentially an electric motor working in reverse. Yeah, okay, but we're only spinning that motor in one axis, aren't we? If you were to take a gimbal setup with a ring within a ring within a ring, and they all have opposing mountings, so that they all, like the way that, you know, the things that keep cups level on ships, like a ship's galley cooker, yeah. But one of those nested circles, if you have a cable connected to the very inner ring that travels all the way through all of the rings, and you twist the cable, all of those rings then spin and do this by virtue of you spinning the one cable at the end, because they're linked. If you then put magnets on each of those rings, could you not create a 3-dimensional equivalent of a dynamo?
Yeah. Do you remember the movie?
Do you know what I mean by that?
Yeah. Do you remember the movie Contact?
Yes, sir.
And the 3-axis ring motor gimbal.
Yeah.
You understand what
and
purpose that was?
And you spin it with a cable from one end, and that will produce so much energy.
They're pumping power into each layer that's self-motorized through the commutators. So no cable, but commutators, which is far more effective.
What was that film with that O'Neill actor where he had that machine
Stargate?
and they opened it? No. It was the scary O'Neill bloke, not Stargate one. So they're in a deep space ship somewhere, and at the end of the ship, the drive of the ship opens the hell gate somehow, and it all goes very wrong.
Oh, I totally know which one you're talking about.
What's that called?
Oh, it'll come to me.
Yeah.
My girlfriend.
It's horrible. It's hideous, this film. It gets very bloody at the end.
It's
Sam Neill. Sam Neill is the actor. It's like
How
a
does
Event
how does this
Horizon.
Event Horizon.
Is it Event Horizon?
Oh no, I think it's
Yeah, with Sam Neill.
Uh,
Well, two people think it's Event
Isn't
Horizon.
isn't that isn't the thing in that a set of
Maybe
wheels
it is.
wheels
Can
within
somebody find a
wheels? That's
picture of
very
that? I haven't seen that.
Ezekiel,
okay, it is
isn't
Event
it?
Horizon. It is. Okay, my bad.
It is, yeah. That's the one.
That's Lawrence Fishburne.
Yeah. Okay, so there's two interesting things that I'll mention about what I just showed. One is that bagel coil. If people here aren't familiar with Bob Greenier's channel and haven't seen O-Day and the donut system, that coil is claimed to do something really special. You hook up a signal generator to it, small audio amplifier, or something else like that. You provide a sine wave signal or some other wave signal. It was only tested with the sine in the Russian paper, and they tested it at 30 hertz because they had a 50 hertz line, so they wanted to differentiate for sure that the signal they were measuring with their oscilloscope-based magnetometer, why I built my magnetometer to replicate, they wanted to verify that it wasn't, line noise. And so they hooked up the generator to that thing. They were measuring the flux in the middle, and then they disconnected the generator, disconnected the wires as well, and continued to measure an oscillating magnetic flux of the roughly same amplitude going through that coil. Now, they'd done many, many tests, and they found that this field would persist in the center self-oscillating magnetic flux for up to 2 days, which is pretty freaking fantastic. But they noticed that if you just poke your finger through the center, you'd completely destroy this oscillation, almost as if there was something physical, like a phantom field in the center, that could be disrupted by physical perturbation or something entering that region. And that makes it sound like it's tied to the local mass or the local matter. It demands that we reconsider the role of the vacuum in terms of magnetic flux.
There's a unifying force there, isn't there?
You know what a flux is?
So
You know what stores the flux?
No, what stores the flux is
it's the core. The core
no,
stores the flux.
they're coreless. These are coreless. They have copper cores, and you could even remove the coil from around this area, and it will persist in that spot. It doesn't even go there anymore.
You're saying a coreless oscillator would self-oscillate without a core?
I'm saying the coreless oscillator will produce a oscillating magnetic field in its center, and then you can take away the coil, the coreless coil, and you'll still have the oscillation in the center, according to the Russian report. And that's why I built that coil, to test this phenomenon as well.
That is interesting.
Oh, yeah, very.
It's like a polarizing.
Jeremiah, can you hear me?
Yeah, I can hear you, G.
We can hear
You're a little
you,
quiet.
So when that oscillating field continues, if that's what you find from your experiment, try popping off a cap, because I've found when I'm doing my experiments and I get this buildup of a field, the only way to get rid of it is to actually have a really hard snap go off in the background, and I use a capacitor to do that. So when you do the experiment, if you find that oscillating field's continued, and you try the finger test, and that sounds kind of funny, but that works out, do me a favor, redo the experiment and try with a capacitor.
Oh, yeah, well, if I can get the self-persisting field, I'm already going to be rejoicing and jumping up and down, because that's an impossible feat of physics that should never happen and is completely unsupported by general relativity, special relativity, or quantum electrodynamics or quantum physics. So this effect would be something brand freaking new that we would demand a change in our current model of the aether or of the vacuum in order to justify. And I'm not saying that I expect it to work. It's a Russian report, it's obscure, and nobody's been able to replicate the effect so far, despite the fact that people have built similar bagel coils. They're not quite like mine, but they built similar bagel coils, and they haven't managed to reproduce this. So I'm not super confident, but hey, if it works, like, I'll be celebrating like crazy. We'll do a stream about it. I'll demonstrate the effect with my new oscilloscope magnetometer probe. And then we can all get crazy about theorizing how in the hell this is physically possible.
What is this about the south field you're talking about here?
This is that bagel coil that we're talking about here.
Bernard, look at your
What about
Twitter
the south
inbox.
field?
I can't hear you. What's that?
What about the south field? It's
Dude, I do not know why you're like 5 feet away from your mic, but please get closer.
Can you hear me?
Wait, just get closer to your. I don't know. Are you wearing a headset? Like you sound. I hear your room echo, like you're in the holodeck that looks like, man. Like it sounds like you're in a big room, dude.
Oh yeah. Do you wanna, Mr. Elon? Do you wanna share screen and share? So, do I just call you Mr. Elon? Do you have what's your actual name?
It's Ian.
Do you wanna
It's
go
just
with-
Ian. Just Ian. Bernard, it's Ian.
Gotcha.
It's Ian.
I love
Mr.
the
Ian.
wordplay. It's Ian. Gotcha. Mr.
Penny
Ian.
drop
Gotcha.
moment.
But yeah, if you want to share your screen and go through some of the AI images you've been generating throughout, as and just
I've just sent you a load. I've sent you some on Facebook.
I know you sent
On
them
Twitter.
my
Sorry, on Twitter.
But sadly, I have 3 different Twitter accounts, and what my main Twitter that you sent it to is still attached to my banned, deleted YouTube channel. So when I'm streaming, I can't really access it. It's like on my phone, sort of thing. Pain in the butt. And if you have it on your computer, if you want to just go through all of them that you've done,
Well, just throw them.
And we can finish
I'll interrupt it. So
I guess
I can go.
Yeah, you've got it set up where they're just behind you there, right there. You can put them up, right?
So you can see here, I'm running Night Vision XL. So this is the SDXL model, but it's a photorealistic model that I use for rendering some of the Truth Seekers show intros and stuff that we do. So
shout out Stephen Camion.
You'll get to see all my So at the moment I've done anti-gravity machine, complex, high detailed machine with twisted copper wiring. That's my prompt there.
I like that prompt. Okay, let's see this.
So I'm going to go through. It's still generating. It's about 30% through a run. So
by the way, let me
go
mention
to infinite image
before I forget,
browsing here.
because I'm probably going to forget this. But while I was putting those 2 magnets together, after I had glued the 2 north sides together, they're 100 millimeters wide. Their diameter is 60 millimeters. They're each 15 thick, so it's 30 tall altogether. I noticed that while I was holding it in my hand before I wrapped it, it was acting like a gyroscope. Like I could feel a strange gyroscopic precession, almost like almost like inertia. But the strange thing about it was that instead of it trying to stay axially aligned with the parallel flat faces as if it was a rotating disc, it seemed like the alignment was completely orthogonal to that, and it wanted to always tilt down 90 degrees. And so it would want to sit upright, standing tall with the hole basically facing parallel to the ground. And it didn't feel like it was trying to pull itself down as if there was an extra force, but it felt like it would fall into that position very, very easily. It would take more force to rotate it until it got into that position when it was parallel with the table surface. It was much easier to turn when it was horizontal with the table surface. So that was something interesting where these 2 pinch magnetic fields acted almost like a magnetic gyroscope. And it's enough to point out where if anybody ever wants to squeeze 2 large magnets together, and you'll only feel this with really big magnets, that you might want to check that out. Maybe it's just me. Maybe I was imagining it, but it's significant if it's actually true.
Right, and this is where I suspect at some points, like AI is gonna accidentally discover a breakthrough.
Oh God, yeah, isn't it?
Putting stuff in like this, right, where it's just gonna show some idea that
What does that look like? What does that look like? That looks like a quantum computer, doesn't it?
Doesn't it?
It's like a fusion machine.
Both. Oh, we got CERN right there by the looks of it, almost more.
I was thinking to ask AI to build a over unity circuit, a simple one, as few as parts as possible.
That looked like Atlas, the last one, right?
I just love the way that it
there's many
efficiently
over-unity circuits
and
out there, depending on
organically
what you're hooked up
designs
to.
things that we wouldn't. Look at that. Wow.
Sorry, Gerald, do you want to repeat that? There's also a couple second time delay, obviously, between Ian and then us in North
Are these
America.
all solid state?
Is there?
Or
Bernard, let's check the time delay. So if I do a count, if I do 1, 2, 3, 4, 5, and then you do 6, 7, 8, 9, 10, the gap between them, if you try and do it as quickly as possible and continue from mine, okay? Yeah? 1, 2, 3, 4, 5.
6, 7, 8, 9, 10.
Exactly. There's no delay. There's no delay.
no
It's
delay
right
at
on.
all.
None.
Wow.
None.
Should that be possible with you in the UK and like me on the west side of North America?
Yes, because we have fiber optic cables traveling underneath the Atlantic Ocean that connect us. So we're communicating at the speed of light.
Fair. Too small.
I mean, there'll be like
fascinating.
It's probably like 150 millisecond delay or something. It's not much. We could probably, in fact, work together with MIDI instruments and remain in time. Almost.
Right? Wow.
Nuts, isn't it? Yeah.
That's just mind-blowing.
That is very interesting. Other fascinating news is it should be just about a week before I get the parts in to build the invisible wall machine for the force field generator. That's going to be fun.
CERN. Yeah, there we go. CERN again.
Right?
What is that? What is that?
I know. I think I needs me one of those. I suspect.
It didn't.
Look
at that one. Oh, this is where I put copper twisted wire in, and it started doing stuff with copper twists.
Damn thing looks like a magnetron.
Right.
Or like the inside framework of the large Searle disk. I like the fact that it actually has a coil somewhere. That's nice.
Yes. And the heat pipes going in and out of it. What are they about? Look at that. God. How can that not work? What does the AI know?
Right? Like, I want to put 1,000,000 volts through these things and see what happens.
I like the twist, too. I like that you can see the twisted conductors going out of the inside. Now, it's not showing, like, the twisted windings, but it's showing twisted conductors that exit. So you got to wonder, it's not like there's a whole bunch of diagrams that it has to draw from about, like, anti-gravity coil systems, right? It doesn't really have much to pull from. So I wonder where this is actually, the information is pouring out of here.
There we go. We're back round again to the start. So, but there you go. Very good.
And I know it's late for G,
definitely
too, so now we're flipping it back around. What have you been up to, man?
I just saw your Gerald, your statement or your message in the background. Do you want to finish the show off with the live demo of your gyroscopic motion from 2 of your coils that they say are solid state without moving parts?
What? Wait, so he's got the same effect too? Really?
Gerald, you're muted if you're trying to talk.
Yeah, can you hear me? My audio seems to be off.
We can hear you now.
I've been using the catch generator for 5 years.
For a while,
I get 10 watts extra out of it.
Just a second, Mike. He's got bad audio. Go ahead, G.
Yeah, I've had it for a while now. I've just been fine-tuning certain things. I've been getting ready to, like I said, show everybody. But I want to get it into 3 or 4 of your different hands so that we can show it all at once and do like a all at the same time demonstration. That way you guys can know I'm not bullshitting. Basically, that's what it comes down to, right? So I haven't really announced it or told a lot of people about it because until the system's sitting in your hands and you guys get to do the same test, it's just talk, right? So that's why I haven't really brought it up. I think I've brought it up a few times to Jeremiah privately, but yeah. I have gyroscopic motion in my hopper and in my, what me and dubbed the warp coil.
How are you testing
It's,
it? Are you picking
over
these
3
up?
feet in diameter, so.
Holy mother of mercy. How are you picking that up? Like, are you physically moving these things while they're operating, or what?
Say that again?
How are you detecting the gyroscopic motion? Is it like a gyroscopic inertia, like it's rotating, or are you picking it up some other way?
Okay, so the way that I'm picking it up, and again, this has to be verified by you guys.
And there goes it.
And I can spin it Sorry?
It's trying to chop your audio.
As soon as you start talking
missed
about
that.
the important facts, it starts cutting you out again.
So right at the beginning of your explanation, your answer to me is right when it cut you.
Okay, so I'll try and do this quick.
Okay.
So I can spin it in rotation, and I can control both axes of a rotation. And speeds in both axes of rotation.
That's the magnet that you're talking about, right?
Did you catch that?
Yeah, you're talking about spinning a magnet, right?
Yeah.
Okay, yeah, and that's spinning a magnet along an axis.
Yeah, just by spinning a magnet. But now...
Wow. Oh, you got Mike back.
Okay, but I'm not just spinning it. I'm not just spinning it on its x-axis. I'm spinning it on its y-axis as well.
Right, and that means you're not...
Does that make sense?
Yeah, the magnet's not rotating so that it's chasing north and south. It's actually rotating like a rotor of a silent pole motor, as if the material itself is being spun not based on where the poles are located, but 90 degrees to the poles, the rotation along an axial rotation.
Yes, but I can also control the flip of the poles.
Are you doing that with duty cycle?
Say that again?
How are you controlling the flip of the poles?
I do it through dumping the back
With
EMF
the
in
sensor.
my secondary coil on the geometrical form itself.
Yeah, that's going to be something better demonstrated.
Back EMF is reverse polarity. That's already flipped the pole. Back EMF is reverse polarity. That's already flipped the pole.
Yeah, but the way that my coil is wound, I capture the back EMF, allowing my primary to have its energy flow through it super quick. I wouldn't say it's a superconductor, but it definitely displays anomalies that need to be demonstrated and tested by others. I'd love to get it into Jeremy's hands, Mike's. I'd love to get it out there so that you guys can all test it all at once.
Well, just get it over here so we can privately verify it, and then we'll go from
now
there.
You can dump the back EMF into a battery.
Well, I'm on my
you can dump
third
it
hopper.
into a coil.
Yeah, I've done that. I've dumped it.
And if you dump it into a
dump
coil,
it into microwave transformers. I could dump it into batteries. I can light banks of LEDs. I'm right now working with my scooter motor that runs at 60 volts, and I've just installed a coil in the system itself to charge my batteries on my trailer while I'm running the scooter itself. So far the tests are pretty mind-blowing. But like I said, it's just talk until it's in your hands.
That's amazing.
well, the confusion comes in when people don't understand. You know, you charge a coil one way, you remove the charge, the poles flip on that coil.
I hear you, Gerald. Gerald, my father used to say there's thems that talk and thems that do.
Mike, Faraday Research, you gotta mute your other speaker. You're causing us mad echo by having two cameras or two microphones, two speakers.
All right.
Is that?
You're getting a longer delay than we've got across the Atlantic.
Right?
Once
Or
you
does someone have YouTube playing still? Gerald, do you have your YouTube on? Or were you watching before? I don't know.
It's
Or
off.
they're just messing with us. As soon as good information happens, this always happens in the stream.
Like to
Bernie, do you
explain how
stream us
I wind the
live?
coils is a little difficult.
Well, I guess it wasn't Mike, he just left. And
We're currently live on Rumble. We're currently live on my two YouTubes, on Alien Scientist Jeremy's YouTube, on Twitter, on Twitch, on Facebook, and anybody else in here, if you want to share part of it to your channel, feel free to hit the top right button, and that's the beauty of StreamYard.
And smash that like button.
Yes, please smash the like button. several times on all your accounts and all your alts. And when are we
Back EMF
wrapping
is
this
a
up
lot
soon,
like what
guys? Because
Newman was using.
I gotta get to bed here, man. It's been a long week.
Absolutely. We're
Yeah,
got
likewise, it's early here.
10 minutes to 2 hours, so we'll say this
Yeah.
10-minute mark and closing.
Go ahead, pop the
thoughts
after
and
party
statements.
link in there. Pop the after party link in the chat. Anthony, I know, wanted to get in the last
I
little bit here.
emailed
So.
Anthony the link a little bit ago, but yeah, let's closing statements, and then there'll be a little after party, but we'll end it at before the 2 hour here. And thank you, everyone. This is epic stuff. And Gerald, do you have a little live demo for the gyroscopic from solid states, or are you not set up at the moment?
I do not, because of the way that I want to demonstrate it. I don't want to demonstrate it with just me. It'll be too easy to call it fake. I want everyone to demonstrate it all at once, and that's coming very, very shortly.
Definitely not fake. I've demonstrated it. I've seen it. Just
I'll
never close
explain
the loop.
in the after party.
Heck yeah, man. Heck yeah.
Right, listen, before we go, just quick. My wife got sent through from AliExpress a weird order, and they accidentally sent her a load of these LD2410C sensors. So I've got about 24 of them in a bag. I presume they were destined for someone else, but how do you go about sorting that out? You know what I mean? These things are pence each. So I currently have one of these connected to a TTGo T-display, which isn't picking up properly on the camera there, a little ESP32 with a built-in
nice.
screen.
Are those just displays for Arduino?
No, that's the whole thing. No. That's an ESP32 and a screen and about 15 digital input general purpose I/O pins around the side.
Oh, damn.
And a USB-C connector and 2 buttons on the front and a reset button on the side. And it's got Wi-Fi and Bluetooth.
Who did that come from? Adafruit?
They're about $10 each. It's a LilyGo T-display. And you run it from the Arduino IDE. So, and I got ChatGPT to write the code for it. So I have one here, and I have another one which I'm putting together as well, which I've probably lost with my cup of tea somewhere. But if anyone here has any experience with these, they're 24 gigahertz sensors. They're human presence sensors. It works in a cone. You get about 5 meters maximum radar, and when you run it, if you buy the LD2410Cs like this one, you can actually run it off like I've got these tiny whoop batteries, the little lipos, and you can literally plug that onto there. Boom, it's now operating. They're flashed with Bluetooth firmware anyway, so you can cut the Arduino out of the situation completely and just connect the battery to the little sensor like that, and then it comes up as a Bluetooth device. And there's an app already on the Android market which takes all the data from it and gives you all these wave bands and everything. And it looks amazing. So I thought I can build an aliens motion tracker out of that beeps and works and does a little radar screen with a dot where it places the thing, and it does static objects and it does moving targets. It gives you the distance to them and everything. I had it set up and put it on the floor before.
The product description is the LD10C is a high sensitivity.
Yeah, amazing.
24 gigahertz human presence status sensing module developed by Highlink. Its working principle is FMCW, frequency modulated continuous waves, to detect human targets in the set space. Combined with radar signal processing and precise human body sensing algorithms, it realizes high sensitivity human presence status. So that's pretty damn cool. So it can detect
okay, that's what these are. Okay. Yes, and humans, and I presume ghosts as well. I figured the fact is you can have.
I like where you're going, man.
It's a ghost detector.
Next
And now,
level.
so it's
Dude, yeah.
it's incredibly expensive to buy a tri-field meter, you see, which is what most people use in ghost detection, or they'll go for one of those. Oh my god, I've got one around here somewhere. One of the things.
I want to know where you're getting within 5 meters of aliens.
It'd work for that too. Oh, that's great. That's a great idea. I love that.
Well, for instance, my friend, so Steve, I just thought if you made a simple latching system that basically charged a lithium battery off a solar cell and then had one of these LDs in the way, you could have a latch basically on the ESP32. So if anyone walks in front of it, it will latch it and count the amount of time something's walked in front of it. So Steve, for instance, has a cabin in the woods, doesn't he? And he has some dickhead local. He has some dickhead neighbour that keeps on pinching his tents, and if he leaves any tools out, or like this neighbour will come and take them down. He'll think that someone's trying to camp on the land, and he goes, "It's private land. You shouldn't be camping there." Steve's going, "But it's my land." So that was the point, to either build human trigger sensors to do a count. That's beautiful. Is it a digital? Is it one with the LEDs, or is it one with the full? Does that have the analog? Don't just show us a tri-field meter and then turn your video off. That was cruel.
Hey, this is like the hunting cams.
Did we lose him?
Well, we had video for a second.
But you get what I mean. So you get what I mean.
Sorry, guys.
I reckon, and I've got a bag of these, so I can make ghost detectors that are literally. I mean, the ESP32s are maybe $8, and these are maybe $1 each when you buy them in bulk. So for less,
You start making
$10,
ghost detectors, I'll sell them through my channel on my website.
Yeah, I'll sell them to our.
I'm just designing. I'm trying to
do it.
design a nice 3D. I'm trying to design a nice 3D printed case for them. So far, I've got this, which I put up on Thingiverse. I've got a nice little snap together case like that, which I've already done.
Planning on, by the way, and I'd love to have that device in there. I'll have to do the I'll have to find a programmer to set it up correctly. But we want to have a website basically where we sell special detection tools. We want to have temporal field displacement meters. We want to have scalar electric potential meters. We want to have we want to have BNC and audible magnetic flux displacement.
So like that, and there's a button there, and a button there, and a USB-C connector there, and there's enough room in there to put the LD 2410C and a lithium polymer battery, so you'll be able to charge it up and then it'll run. If you long press the reset button, it switches itself off, so you can charge the battery and have it turned on when you want. And the beauty being, not only does it work and put the data out to the screen here, but you can also, there's also an Arduino app, and they're Bluetooth enabled by virtue, so you can just connect to it and do it through your phone, walk off, leave them in a room to see if there's a ghost in the room.
Oh yeah, no, I like that idea, and I also like the possibility of what else it may be able to detect.
Yeah, exactly. Yes, yeah.
Fields. So,
well, it does cats. I've checked it tonight, and it does cats. Mostly cats, really.
Yeah, like I said, we want to have a specialty website that sells electronic tools and detection mechanisms or detection devices that you can't buy right now, that are more complicated to build, or even things that are simple to build, but people just simply don't have the infrastructure, the tools to do them. And we would love ghost detectors. We would love.
I open source everything that I make. I end up open sourcing and doing a makey doey, and then making no money from it whatsoever.
Well, the money isn't from trying to lock down the idea. Like we'll offer the schematics and everything.
That's why,
you can do your own PCB files, but the whole thing is like, here's a kit where if you don't want to order all the stuff alone, if you don't want to go on a Mouser and select the parts list. Or the
this is why you shouldn't smoke cannabis, you see, because it turns you into a big soft hippie.
Nothing wrong with that. Soft hippie.
Some people need it.
Hippie is fine.
Too late.
I just took my harvest.
So high strong that they need that, you know.
I just took my harvest down. I just took my harvest down, and I got about 1.5 pounds of mimosa, which I've got in jars.
Oh, I know the mimosa smell. Like it just.
Oh, it's beautiful. It's like Chemdog with a Oh, I
love
sort
it.
of
Oh, here
musky
you go,
fruit
Jeremy.
edge on the back of it. It's beautiful. Very nice.
Oh man, yeah. Like how many people are going to buy a ghost detector or a time field meter? That's definitely
would.
something that I think a lot of people need. I know, like Faraday's stuff. If he put that around his coils, he'd probably pick up a temporal field.
Well, look, do you want me to try? I'm going to model up a case for this that looks like a ghost detector, and I can model an alien scientist specific one if you want.
Take it to Skinwalker
If you want
Ranch.
to market that.
Yes, please.
Yeah, we haven't got
I
all of our
can.
stuff
I'll run
back
you
yet.
off a prototype of it. I've got some engineering resin. I've only got resin printers now, and I've got some engineering resin. Really nice, high impact stuff. So you can throw.
Right, like what I want to do is I want to coordinate our company with Michael Perone's company, so that he's going to be producing materials. I want those to be on our website. I want all of our specialty meters to be on the website. I want high voltage multipliers, things like the Electromagnetic wand kit and the tiny Titan Tesla coil to be up there.
Yes.
There are so many things that need to be there that we could sell that simply people don't want to have to build because they're freaking complicated or they're too much of a pain in the ass to get started on. And we don't have to charge a lot for them. Like these things, we're not talking about like trying to charge specialty prices, but just basically reasonable things where we cover our costs, we cover our infrastructure, and we make enough to continue to grow the business. So it's a very fair idea. And all these ideas, like there are so many people that have these little ideas, and you get a commission from it. Submit the ideas, we optimize the circuit, we sell it. You get a cut from that, or you just outright sell the idea, and then we go from there. We're not going to patent any of these things. They're going to be open source, so we're not worrying about any of that legal bullshit. No
the thing is with one of these things, if someone does have their own 3D printer, then that's why they bought their 3D printer, to be able to shortcut these things. So if you put the model for the case and you put the plans up on the site, people can make it themselves if they want, but the best, but you know, because that's the best way of doing it, because as soon as you put a product out,
you got an NFT.
You've got maybe a month, you've got a month, maybe 2 months before you get Chinese copies of the product anyway.
Right, like Ian, like the other thing about it though is too is like imagine your circuit takes about 40 parts and a printed circuit board that you have to order, and generally they're like $15 for like 10 or 15 of them, so you got to order a whole bunch of them. If you don't want to do all that, you don't want to outsource the 40 individual parts, you don't want to outsource the connectors and have to go and do the individual selection of parts, then here's a way to get it all at once.
There's the parts.
And you pay like, a 30%.
There's a battery, there's the TTGO display, and there's the LD2410C. There you go. That's everything. And as well as that, because that's already got Bluetooth built into it, and you can connect that to your phone come what may. In fact, I think you can even configure it, tune the distances and stuff from the app on the phone. You're just purely using this for data. It's also got Wi-Fi and Bluetooth. So if you give that your SSID and password for your Wi-Fi, you can create a HTML front end for that and be able to connect to it from your laptop as well, and then make that really nice graphic. There's a 3-dimensional aspect to it as well. It's not just a distance. It does a
grid. It does like
it's like a light field almost. It's beautiful. It's beautiful the way to do it. I wanted to have this kind of, that American football field gradiented lines in like a dark green with a neon green on top of it, and then have the objects placed as red dots. It's a radar. It's radar. By the way, my uncle worked on the deployable radar in World War II when the Germans bombed our airfields. Lord Admiral Dowding was instructed to give us a kind of second chance there. So he developed mobile truck-based radar, which could be deployed in the event that the airfield's radar was destroyed. And my uncle worked on that radar. So I'm quite keen to get into doing that.
That's awesome.
He would be proud.
Well, it's about time for the outro, Bernie. So everyone that's in the after party, stick around.
Thank you, everybody, for watching. And yeah, the StreamYard link posted for the after party if you want to join and talk. Sure, some will be sticking around, and we will do this all again soon, because each one of these sessions, it's bringing out technology, ideas, discoveries.
It's awesome, isn't it?
Open sourcing it. It's what needs to be. Thank you all. Catch you on the next one.